In grade 11, you memorized some angles and what sine, cos, and tan were for certain special angles. You might remember tan of 45 degrees was equal to 1. You might have forgotten that. That's okay. We're going to rememorize them and add things to it as well, and it becomes a little bit easier when we connect it to the unit circle. So what we're going to do is we're going to split our unit circle up into families according to the reference angles. So the first family that we're going to look at are all of the points on the unit circle, so we can label them, and I'll label the points in red. All of the points that end up on the axes, either the x-axis or the y-axis. And we're going to start with degrees, because degrees is something we know. I'm going to choose a spot. Does it make sense that that's 0 degrees in standard position? If you went to the y-axis, it would be 90 degrees in standard position. Here we would have 180 degrees, 270 degrees, and if you went all the way around again, you would have 360 degrees. And we could keep going, but we'll just go once around the circle. Yes? In this, whatever color code you've decided. Next, we'll do the same thing and put our values in radians. So 0 degrees is the same as 0 radians. 90 degrees is the same as pi over 2 radians. Because if halfway around the circle is pi radians, then 90 degrees would be pi over 2. 270 degrees, 1 pi over 2, 2 pi over 2, 3 pi over 2, because it's 3 90s. And all the way around the circle is also 2 pi. Now, if this is a unit circle, and the radius is 1, does it make sense that the coordinates of this point, if this radius was 1, would be 1, comma, 0? If the radius is 1, this point would be at 0, comma, 1. This point would be at negative 1, comma, 0. And here we would have 0, comma, negative 1. And this is where one of our big ideas really takes effect early. Because we can label those points, and because one of our big ideas was any coordinate on the unit circle is cos theta, comma, sine theta, just by labeling those points, you can now do mental math with sine and cos and all of those angles. If I say, what is cos of 180 degrees? The answer is up there. Cos of 180 degrees is negative 1. Because cos of the angle is always the x-coordinate on your unit circle. If I said, what is sine of pi over 2? So now you can think in radians. Pi over 2 is right here. Sine is always your y-coordinate. Sine of pi over 2 would be equal to 1. And so now you can do mental math with all of those. Cos of 270 degrees, 0. Sine of 270 degrees, negative 1. Cos of 2 pi, 1. So we just need to know the coordinates, and then we can know sine and cos of all of those angles. And since we have a unit circle where the radius is 1, all of those coordinates on the axes are easy to find. We can also, and we're going to label it in black, what's tan of 0? Well, our other big idea is that tan is always sine over cos, which on our unit circle means the y-coordinate divided by the x-coordinate. So tan of 0 will be 0. For the same reason, tan of pi will be 0. And when we get to an angle of pi over 2, tan of pi over 2, if we did sine divided by cos, or the y-coordinate divided by the x-coordinate, would equal 1 over 0. Are you allowed to divide by 0? No. So we would say this is undefined. And same thing down here. Tan of 3 pi over 2 is undefined as well. So just by labeling the points on the unit circle, you can now do sine, cos, and tan really quickly. So the next family that we look at is the 45-degree family. Now, the 45-degree family includes all angles that have a reference angle of 45 degrees. So if I start in degrees and say this angle in standard position would be 45 degrees, if this reference angle is 45 degrees, what is this angle in standard position? 135. Whoops. So this one's 45, this one will be 135. If my reference angle is 45 degrees, what's the angle going to be in quadrant 3? 225 degrees. What's the 45-degree family member in quadrant 4? 315. How did I get the 35 degrees? Did you get at 35? Did anyone do 180 minus 45? Does that make sense for quadrant 2? Because now we're going to do it in radians. 45 degrees is pi over 4. What would be the family member in quadrant 2? Instead of doing 180 minus 45, now we're thinking in radians. You're going to have to do pi minus pi over 4. How do you subtract fractions? What do you need to subtract fractions? Common denominator. Are you okay to change that pi to 4 pi over 4? And we get 3 pi over 4. What's it going to be in quadrant 3? Five pi over 4. What's it going to be in quadrant 4? 7 pi over 4. Now, to find our coordinates on the unit circle, we're going to need to know what sine of 45 degrees, cos of 45 degrees are. And you have this little bit of space on your page right here. We're going to draw the same triangle. So I'm going to label up here, special triangle for 45 degrees. The same triangle you probably drew back in grade 11 so that you could remember what sine of 45 degrees, cos of 45 degrees, and tan of 45 degrees was. The special triangle, well, in order to know sine, cos, and tan, we know that for right-angled triangles, sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. And if I make one of the angles 45 degrees, I can figure out the other angle. Because the triangle has to add up to 180. What's the other angle going to be? Also 45 degrees. This makes this triangle special not just because it's a right triangle, but what other kind of triangle? Do you remember the name for that triangle when two angles were the same? Isosceles. And an isosceles triangle has two angles that are the same and two sides are the same. In fact, this side and this side are going to be the same. And it doesn't matter what value you put in for them. I'm going to choose and say this side is 1, then this side is 1. How long is my hypotenuse? Close. It's close to 2. Root 2. Yes. A squared plus b squared equals c squared. This will be root 2. And by drawing that triangle, you can now say that you know what sine of 45 degrees is, what cos of 45 degrees is, and what tan of 45 degrees is. Because sine is opposite over hypotenuse. And we are going to rationalize the denominator here and write this as root 2 over 2. Cos of 45 degrees, adjacent over hypotenuse. Can you see that that's also going to be exactly the same? So I'm just going to write root 2 over 2 right away. And tan of 45 degrees, opposite over adjacent, is 1. Now, had I chose other numbers other than 1, all of those ratios would have simplified to be exactly the same thing. Can you see that if I would have chosen 3 and 3, tan would still be 1? Because 3 over 3 is 1. If I chose 7 and 7, tan would still be 1. Sine and cos would still simplify to be root 2 over 2. Doesn't matter how big or how small. Whenever you have 45 degrees, the sine ratio is always root 2 over 2. So what does that mean? Well, that means we can now label this point. Because our big idea says the x-coordinate is cos and the y-coordinate is sine. So cos of 45 degrees, that's root 2 over 2. Sine of 45 degrees, that's root 2 over 2. When I move over into quadrant 2, can you see that the y value is exactly the same? It also has to be root 2 over 2. And since those are the exact same angles, my x value is the same, but now it's in quadrant 2. My x value would have to be negative. In quadrant 3, it's the same x value as quadrant 2. It would be negative. Now my y value is going down, but it's going down the same amount. It's going to be negative root 2 over 2 and negative root 2 over 2. And finally, in quadrant 4, the x value is positive and the y value is negative. If your x-coordinate is cos and your y-coordinate is sine, can you see that the cast rule makes sense with the coordinates? Both sine and cos are negative in quadrant 3. Both sine and cos are positive in quadrant 1. Only sine is positive in quadrant 2, and only cosine is positive in quadrant 4. So we can label our coordinates just by where they are. We'll know which one's positive and which one's negative by what quadrant they're in. But the cast rule also makes sense for each of the points. Okay, we're going to do some mental math now. Who wants to go first? Of course, everybody volunteers. All right, Jesse's going to pick the first volunteer. First volunteer is going to tell me what sine of pi over 4 is. Okay, the answer's up here. What is sine of pi over 4? So remember the big idea on our unit circle, that whenever we write the coordinates are always cos theta comma sine theta. So sine theta is your y-coordinate. You go back to our family here. We're at pi over 4, 45 degrees. What is sine of pi over 4? Root 2 over 2. Perfect. You get to pick the next volunteer. What is cos of 225 degrees? Kobe. Negative root 2 over 2. What is sine of 315 degrees? Root 2 over 2. Sine? Sine the x-coordinate or the y-coordinate? It's negative root 2 over 2. It'll be the y-coordinate. And from these, we can also write tan. Tan of pi over 4 is going to be equal to 1. Tan of 3 pi over 4 is going to equal negative 1. Tan of 5 pi over 4 is equal to positive 1. And tan of 7 pi over 4 is equal to negative 1. The cast rule is the same here. Because they all have the same reference angle, the tan value is going to be the same for all of them. Just some are positive and some are negative. Our next family is the pi over 6 family. So what's going to happen now, pi over 6 or 30 degrees. I'm going to write the first one, 30 degrees. Then you have a 10-second head start to do the others in degrees. Go. That was 10 seconds. How did you do? Radians are a little bit harder. I'll give you the first one. We're now in radians. 30 degrees is pi over 6. 20-second head start. See if you can label the rest in radians. How did you do? 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now these were values, sine, cos, tan of 30 degrees, were values that you memorized back in grade 11. In the space between the two circles, the special triangle for 30 degrees is also the special triangle for 60 degrees. Because if you draw a right angle triangle and you label one of the angles as 30 degrees, if it adds up to 180, what's the other angle? 60 degrees. Now last time, when we did 45 degrees, it made an isosceles triangle. And an isosceles triangle is special. It has special properties. There is a name for a triangle where all the sides or all the angles are different. They gave it a name because it's really not a special triangle at all. It has no special properties other than everything's different. But I guess they didn't want it to feel bad because they, like, isosceles triangle had a special name. Equilateral triangle had a special name. So they said, well, we'll give a special name for the triangles that aren't special. Do you know what that name is? Scalene. It's even kind of scaly. It's like, I don't know. It's like, even its name, it's sort of like not even that nice sounding. It's a scalene triangle. So what do we know about this triangle right now? Yeah, All the sides are different. And so this scalene triangle, it's like kind of sad. It's like, I'm not special. Walking down the street, meets another triangle just like it, says hi, and the other triangle says hi. Are you special? No, I'm not special either. Okay. So these two triangles, two not special triangles, they get together because they're both not special. They become friends. And if I draw the other not special triangle right beside it, together they become something special. Putting those two triangles together, what kind of triangle does it make? It makes an equilateral triangle. And if you have an equilateral triangle, all the sides are going to be the same. So I could say, I could pick any length that I like, but I'm going to choose 2, because if I choose 2 for this side and 2 for this side, that means my bottom is 2. But since my bottom is split perfectly in half, because those triangles are the same, that would be 1 and 1. And then I could do a squared plus b squared equals c squared and figure out that the height is going to be the square root of 3. Why is that nice? Well, now I can say that sine of 30 degrees, which is opposite the 30 over the hypotenuse, is 1 over 2. And cos of 30 degrees, adjacent over hypotenuse, is root 3 over 2. And tan of 30 degrees, opposite over adjacent, is 1 over root 3. And again, we will rationalize this. And write that as root 3 over 3. And since we're going to need it later as well, I will also write down sine of 60 degrees, opposite over hypotenuse, cos of 60 degrees, adjacent over hypotenuse, and tan of 60 degrees, opposite over adjacent, which is just the square root of 3. Since we drew that special triangle, we can now go back to our unit circle, and we can say, since cos of 30 degrees is root 3 over 2, I know that my x-coordinate is root 3 over 2. And since sine of 30 degrees is 1/2, I know that my y-coordinate is 1/2. I'll give you a 10-second head start to write the rest of the coordinates. How did you do? All of the values stay the same, just some are negative and some are positive, and that follows the cast rule, or just follows regular plotting points rules. If you plot a point in quadrant 3, both the x-coordinate and the y-coordinate are going to be negative. And if you think about sine and cos in quadrant 3, both sine and cos, according to the cast rule, are going to be negative. And finally, from your triangle, tan of 30 degrees, or tan of pi over 6, is equal to root 3 over 3. 10-second head start to finish your tans. And where did we end up last time with our mental math? Who's the last person to go? Sam? Sam, you get to pick a volunteer. Jesse? All right. Jesse, what's cos of 5 pi over 6? Negative root 3 over 2. Perfect. All right, pick a volunteer. What is sine of 330 degrees? Sine of 330 degrees. Close. Close. Sine is the x-coordinate or the y-coordinate. Sine will be the y-coordinate, so you go 330 degrees. Sine of 330 degrees be negative half. Carter, pick someone for tan of 210 degrees. Nico. Tan of 210 degrees. Root 3 over 3. Perfect. And since we drew our special triangle for 30 degrees, we can do our pi over 3 or 60 degree family. I am going to go and write 60 degrees and pi over 3 and give you 20 seconds to finish the rest of the pi over 3 family in degrees and radians. How did you do? I'll also give you the coordinates in red. As well as tan. And give you 20 seconds to finish the coordinates and all the tan values. And we're on Nico for mental math, so now I can say, what is sine of 120 degrees? Who are you going to pick? Brandon. Sine of 120 degrees. Excellent. What is cos of 4 pi over 3? Cos of 4 pi over 3. Close. It's going to be here in quadrant 3, so your x-coordinate is going to be negative 1/2. What is sine of 60 degrees? Root 3 over 2. Excellent. And tan of 300 degrees. Yes. Negative square root of 3. Perfect. Now what's going to happen next is we take all of this, and this is the only time that this happens during the year, and I give you your next quiz, exactly as it will be on your next quiz. And you put all of the information that you have on all 4 families, all of it all together on one page. And your next quiz will be that page. You have to label every single blank, and there's a chart at the bottom.